Good morning, everyone. The solution to difference equations, part 2, will be discussed in today's class. Let me share my screen right now. Yes. So, the problems what we had done previously was regarding only the forced solution. Now, in order to find out the total solution of the given difference equation, I need to find out the natural response of the system, and later on I need to have the forced response also being considered with a given input. Now, the problem goes this way. Find the solution find the solution of the difference equation of the difference equation of the difference equation given below given below as y of n minus 0.6 y of n minus 1 0.6 y of n minus 1, that will be equal to x of n, that will be equal to 0.4 whole raised to the power n, 0.4 power n, where n greater than or equal to 0. So what I mean here is 0.4 power n. So this would be a right-handed signal for n greater than or equal to 0 given initial conditions, given initial conditions, given initial conditions. Okay, y of minus 1 equals 10, y of minus 1 equals 10. Now I have this initial condition where y of minus 1 will be equal to 10 here. So what it means is, once I have the constant what I need to find out, so once I give n is equal to minus 1, I'll be getting the value of the output, the response of the system will be equal to 10 here. Okay, so what do I need to do here is y total, that would be equal to y n of n plus y f of n. Okay, so I have the total response of the system being equal to the natural response plus forced response of the system. So this is the total response of the system. Total response of the system. Total response of the system. I can write it like this. Now this one is the natural response. This one is the natural response of the system. Natural response. This one is the forced response of the system. Forced response of the system. Okay, so first one is the natural response, what we are going to find out. Next we are going to find out the forced response of the system. Next we are going to find out the forced response of the system. Now first one, to find natural response of the system. To find the natural response of the system. Natural response of the system. Okay, so to find the natural response of the system, say yn of n. So what you need to do? First, you need to figure out the characteristic equation. You have to figure out the characteristic equation. Okay, so to figure out the characteristic equation, what you need to do? So you can write it as 1 minus 0.6 z to the power minus 1, that would be equal to 0. So z minus 0.6, that would be equal to 0. Z will be equal to 0.6. So one of the root of the characteristic equation, I have z is equal to 0.6. So next one, what I'll be having is yn of n. So that is equal to k. What is that? That is 0.6 whole raised to the power n. So yn of n, that would be equal to 0.6 whole raised to the power n. So that is what I mean here. So yn of n, that would be equal to k times 0.6 power n. So that is the characteristic equation what you are going to get at here as the natural response of the system. So I have figured out the natural response of the system. I have figured out the natural response of the system. I have figured out the natural response of the system. Fine. So now after figuring out the natural response of the system, what I need to do next is to find forced response of the system. Forced response, forced response of the system. Force the response of the system. So to find the forced response of the system, what you need to consider? So you need to consider the input. What is the input that is there? I have zero point 0.4 power n. So this is quite similar to alpha power n, where alpha would be equal to 0.4. So now with the given input, the structure of the forced response. I'll be very clear now. The structure of the forced response. The structure of the forced response. So how would be the structure of the forced response? That is yf of n. Constant called as c. So you have the input which is there 0.4 power n. So this is the input c times alpha power n. So alpha would be 0.4 power n. So now I have yf of n minus 1. Why did I take yf of n minus 1? So I have y of n minus 0.6 times y of n minus 1. That would be equal to 0.4 power n given in the numerical problem. So replacing y of n with yf of n. So I have yf of n minus 0.6 times yf of n minus 1. That would be equal to the input that is considered. Upon application of the input, I have 0.4 power n. So now that is yf of n minus 1. So in place of n, I would be replacing it with n minus 1. So that is written like this. So on further simplification, I can change it. C times 0.4 power n into 0.4 power minus 1. So 1 divided by 0.4. That is there. So where you are going to have 1.5, that is there. So 0.4 power n minus 1. So you are going to have 1.5, that is there, c times 0.4 power n. So yf of n minus 1, that is 1.5 c times 0.4 power n. So this is what you are going to have it. So yf of n, so will be written like this. Yf of n minus 1 will be written like 1.5 times c multiplied with 0.4 power n. So yf of n, c times 0.4 power n, yf of n minus 1, I have 1.5 times c multiplied with 0.4 power n. Next one, I'm going to replace it in the difference equation what I have there. So I'll be having c times 0.4 power n minus, I have 0.6. So I think I should have changed here. I'll be having I just wrote it as 0.6 multiplied with 0.4 whole raised to the power minus 1. So I'll be having the total cumulative one. So 0.4 power minus 1. It is 1 divided by 0.4. That is, you're going to have 1 divided by, that is 10 by 4. That is 2.5. Okay. So 2.5 is there. So a slight change what you can make here. 2.5 multiplied with 0.6. Okay. So 2.5 multiplied with 0.6 there. Okay, that is 1.5. I have written directly, and what you can make here is you can just slightly change according to the requirement, and you are going to have c times 0.4 power n minus 1. So I have replaced it here, directly changing to n rising to the power. What you are going to have n minus 1. Okay, so what needs to be done here is 0.4 power n minus 0.6 into 2.5 times c 0.4 power n, that would be equal to 0.4 power n. So c minus this value, that is 1.5 c, that is there. So you are going to have 0.4 power n, that would be equal to 0.4 power n. So c minus 1.1 minus 1.5, that is 0.5 with a negative sign c, that would be equal to 1. C would be equal to minus 1 divided by 0.5. Okay, so that is what you have here. So 1 divided by 0.5, 1 divided by 0.5. So you're going to get c certainly as minus 2. You're going to get C as -2. So the forced response of the system YF of n, so you'll be having -2 multiplied with, there is no other repetitive roots being present there, so you can write it to be 0.2 multiplied with 0.4 power n. Okay, so that is one thing that you're going to get, and the total response of the system. The total response of the system, of the system would be y of n, that is equal to yn of n plus yf of n. So y of n will be equal to yn of n plus yf of n. So y of n, that would be equal to k times 0.6 power n minus 2.4 power n. So that is y of n. So now the main thing is to find out the k constant that is there here. So what you need to do, you need to have the initial conditions that is there. So y of -1, it will be equal to 10 there. So that is equal to 10 k times 0.6 power -1 minus 2 times 0.4 -1, that is there. So the value of k would be equal to, so depending on the value of n that you have given as -1, the value of k would be equal to 9. The value of k would be equal to 9. You can check it out and substitute the value of k again here. So in the difference equation, the overall solution, that is the total solution, would be 9 times 0.6 power n minus 2.4 power n. So that is the overall solution, overall response of the system. That is the total response of the system. That is the total response of the system. Is the total response of the system, what you have here. So this is the way in which you can proceed with the given solution. So let me just highlight here. So you are going to have the natural response of the system to be found initially. Next, you are going to find out the forced response of the system. And later on, after finding out the natural response, depending on the characteristic equation, so you have yn of n to be equal to k times 0.6 power n. So that is there. And depending on the input, so this is the input x of n applied to the difference equations, I have the structure of the force response depending on the input that is given there. So this would be the structure of the force response. I have the overall solution of the given equation, and I can find out the unknown constant c would be equal to -2. So y of will be equal to -2 raised to the 2 multiplied with 0.4 power n. So now I have the total response of the system. Say y of n will be equal to yn of n plus yf of n. To find out the constant k, so take initial conditions given in the problem, as y of -1 will be equal to 10. So I have y of -1 will be equal to 10, and I can substitute the value of the initial conditions to find out the value of k as +9. Okay, so the total response of the system would be 9 multiplied with 0.6 power n minus 2 multiplied with 0.4 power n. So with this note, I would like to give two more problems that is there. The second problem, that is y of n plus 0.1 y of n minus 1 minus 0.3 y of n minus 2. That would be equal to 2 times u of n. So you have to evaluate the natural response, forced response, and the total response of the system. So y of -1, that would be equal to 0. Y of -2, that would be equal to 0. Evaluate the natural response, forced response, and total response of the system. Total response of the system. So you have to evaluate the natural response of the system, forced response, total response of the system that is there, and this is the given difference equation what you have here. Okay, you have to evaluate all these things, and these are the initial conditions given. initial conditions given specified, or initial conditions given specified, where y of minus 1 will be equal to 0 equals y of minus 2. Okay, so I can give this a problem to Sakina. Okay, she will be able to solve this and get the answer. So the third problem, I have again y of n plus 4y of n minus 1 plus 4y of n minus 2. That would be equal to 2 power n u of n. So y of minus 1 equals 0, and y of minus 2, that would be equal to 1. Okay, so this is the difference equation that you have to find out the natural response. The natural response. Next one is the forced response. Forced response. Third one is the total response. Third one is the total response. So you have to find out the natural response, forced response, and also the total response that is there. So this problem, I think Rohini MV can solve it and find out the answer. Next, fourth one. So for the system given below, for the system given below, find the total response. Find the total response where y of n plus 2 plus 4 times y of n plus 1 plus 4 y of n, that would be equal to 2 power n u of n. So where y of minus 1 would be equal to 0, y of minus 2, that would be equal to 1. So you have to find out y of n. So that's the unknown. Y of n is the unknown. Yn of n, that is the unknown again. Yf of n, that is also the unknown. So you have to find out y of n, yn of n, and yf of n. So where you have the y of n being the sum of both the natural response and also the forced response of the system. Okay, so that is one thing that you will be finding out. Okay, so I can give this problem to Mohan. Mohan can be able to solve this and send me the solution within today. Okay, so with this note, I would like to end the session of today's class. In the next class, what we are going to discuss is regarding the solution to difference equations by considering the zero input response and also the zero state response. Okay, so let me stop and thank you everyone. Thank you.